Hey all, this is Alan with Bothell STEM Coach, and today we are going to be doing the 2018 AP Calculus BC free response questions. Now, I don't do all the BC questions because half of the questions already are part of the videos in the AP Calculus AB section. So 3 of the BC questions are just different from the AB questions, and so I'll just be focusing on the 3 that are different for the Calculus BC exam here. So researchers on a boat are investigating plankton cells in SC at a depth h meters. The density of plankton and cells in millions of cells per cubic meter is modeled by this. For 0 less than equal to h less than 30 is modeled by f of h. So this is, what is it, millions of cells. This is a density. This is a density here. Using correct units to interpret the meaning of the derivative in 25. So this is density in cells per cubic meter, but the slope of that is divided by meters. So the units, 25, the units of this are cells per cubic meter per meter, right? And what this represents is it represents the rate, sorry, the change in density per meter at 25 meters. So it's the rate that the density is changing per meter at 25 meters. That's what that slope represents. It's the change in density divided by the change in the height. So it's each meter you go down, or per meter you go down, it is the rate that the density is changing, which is in cells per meter cubed. Okay, consider a vertical column of water in sea with a horizontal cross-sectional constant area of 3 square meters. So I have, we'll say it's a square. It doesn't really matter what shape it is in this case. I have a column of water. This area is 3 square meters. To the nearest million, how many plankton scales are in there? Okay, well, in general, if I need to take a slice of this, a little thickness slice here, and I want to figure out how much plankton is in this little thickness slice. So this has a height dh, right? Thickness dh, because I'm going to integrate over dh. So I've sliced it in the h direction, the vertical direction. This is h. And I've taken a slice, and I want to find the amount of plankton. The amount of plankton would be the density of plankton times the volume of the plankton. And the volume of the plankton is the density times dh times 3. Because it's the area of this square, or the cross-sectional area times the depth. So the amount of plankton in here is 3 rho dh. And what I want to calculate is the entire density, not the entire density, but how many. So this is how much plankton is in there. I've taken the density, I've multiplied it by the volume, and so when I've done that, this gives me the number of plankton in this region, and I want to sum up all of the plankton in that region from 0 to 30. Yeah, 0 to 30. Okay, so I'm going to use my calculator to do this. So what I'm going to do 3 times rho, which is 0.2 x squared, e to the negative 0.0025 x squared. Integrating over x, I'm integrating from 0 to 30. So I get 1675. And this is in millions of cells. And they went to the nearest, so 65 million cells. All right. Oh, sorry, that's getting cut off a little bit. You got the number, though. I didn't realize I forgot the calculator was going to cut that off. Okay, that's close. That's good enough. There's a function u such that 0 less than or equal to f of h is less than or equal to u of h for all h greater than, and the integral from 30 to infinity of u of h dv is equal to 105. Okay, the column of water part B is k meters deep. where K is greater than 30. Write an expression involving one or more integrals that gives the number of plankton cells in millions in the entire column. Explain why the number of plankton cells is less than or equal to 2,000 million. There is a function such that for the depth beyond 30, that this function is bigger than f of h, and also the sum of everything past 30 meters is 105. Well, I mean, basically, they're trying to say like why the plankton. If I want the total number of planktons in the entire column, and I'm going from 0 to k of f of h. Oh, f of h is for the depth after 30. Oh, I got it. I understand now. Okay. All right. I get it now. Okay, what they're saying is, so I've gotten the portion for the first 30 meters from part B. So the part B, I did 0 to 30 because I did row of h right here. I didn't really read this part. This part is for the density after 30. So if I'm going to do this column of water, I'm going to do it for the infinite. What they're saying is the upper bound on the total, like, okay, so I want to calculate how many cells are between 30 and a million, 30 to infinity. And again, I do 3 times f of h dh, okay? Now I know because f of h is smaller than u of h, this has to be smaller than 30 to infinity, 3 times u of h dh, right? And because u of h, we know that this integral, if I bring this 3 out, it's 3 times 105, or that's 315 million. So that means the total integral of all of the total, which is equal to 16, it has to be smaller than 1675 plus 315, and that's 1990. And so that demonstrates why it's smaller. Because whatever this quantity is, which is the total amount afterwards, that has to be smaller than 315 million. That means the total amount has to be smaller than 1990 million. Okay, which is less than 2,000. Yeah, I got 1990. So anyway, the boat is moving on the surface of the sea. At time t equals 0, the position of the boat is x of t, y t, where x prime of t is 662 sine 5t, and y prime of t is 880 cosine 6t. Time t is measured in hours, and x of t and y of t are measured in meters. Find the total distance traveled by the boat over the time interval. Okay, so total distance traveled is going to be the square root of dx dt squared plus dy dt squared. It's going to be kind of like arc length a little bit. And I'm going to go from 0 to 1. And so I know what x prime and y prime, so I just kind of plug that into my calculator. So math, oops, it turned off, math. We're going to integrate square root of dx dt, which is 662 sine 5x. Squared plus I need to square all of that thing, so I need to be a little careful here. Because I got to square the 662 also. Plus 880 cosine of 6t squared. So I did the square root of all of that. I'm integrating x. I'm integrating from 0 to 1. Oh, whoops. What did I do? Okay. I closed the square. No, I closed. Oh, I didn't. I forgot one more here. Got a parentheses. Always a problem with using these. It's hard to read. You got to count parentheses all day. 757. And what is measured in hours? Meters. Okay, let's see how we did on the solutions. That is not what I want to look at. Question 2. Negative. Oh, I actually wanted you to compute the derivative. I don't know why I didn't. Oh, it said find it. I didn't actually compute the derivative. Let's just do that real quick. P prime of h. Oh, your calculator can do that. Let's. This is the calculator portion. So let's do n derivative. The function is 0.2 x squared e to the negative 0.0025x squared. Derivative with respect to x, and I'm taking the derivative at 25. So it's negative 1.179 cells per meter cubed per meter. It's decreasing at that rate. The density is decreasing as it gets deeper at that point. So that's what it's saying. Okay, per cubic meter per meter. So 1675, we got that. Total number of is bounded by that. Good. And that is 757 meters. Is that what I got? 757. Yep. Okay. Hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.